Hello, my name is Ahmad Shafiq bin Sabahul Ahmad. I'm the leader for the Integrasi Team 2 from UKM. So our project name is SALAM, which dubbed as Smart Cloud-based Temperature Screening and Attendance Management System. These are our team members. Dr. Hanif is our supervisor, the main supervisor for this project, and we have Prof. Aini and Dr. Hafida, and Hassan as our software developer. Me, myself, Ahmad Shafiq as hardware architecture developer or embedded system developer, and Husna also the software developer. We are engineering student. I and Hassan from mechanical department, and Husna is from electrical department. Okay, so the introduction. So this system it consists of hardware to collect the sensor data. For our project, it is the temperature sensor unit that used for screening, temperature screening. So we also integrate it with the web-based system, which uses cloud system. So it's very our system is developed to be very highly configurable web-based system, and it consists of multiple hardware device where we have temperature reading and also card reader reading, which is to record the identification number, where we can place it on multiple location. And we use cloud-based system to transfer to transport the temperature reading and also the card reader reading to the cloud, to the online database, store it, and from the cloud we can do analysis, data analytic, and then display the data and show the analytical results. And also we have also developed a smartphone based app where it linked to our cloud system to display the data and also send the status update to the cloud. So the uniqueness of this project is it's very highly configurable, which allow flexibility and also low cost and easy extensible, where I can say it is highly scalable. Okay, so this project is initially developed as public service effort to reduce the COVID wave before this, and with still ongoing development. Okay, so the problem statement. So as we know, we have to control the public place and we have to monitor it to minimize the virus spreading. So we know that to reduce the infection risk, we have to check and track the attendees. And we have to avoid, or we have to prohibit individual that have sickness or high temperature. Okay, so the objective of this project is to help reduce the spread of COVID by using smart monitoring of the participant. And then we want to capture the data, the temperature data. As you can see the picture here, we have developed this capturing the data capturing device. It will send to the cloud. This what we call remote terminal unit, RTU, where it captured the temperature reading, the user temperature reading, and then it will also collect the card reader reading. For example, a student want to enter a class, she or he have to tap his or her metric card to this device, so we can log it, and also the temperature to make sure his or her temperature is safe. Okay, and then we want to monitor and manage the individual attendance. Okay, and we want to make sure the attendee temperature is within the safe value. We will see how the project is done in demonstration part. Okay, so for the methodology, I will explain how the temperature reading and also the card reading is transferred to the cloud system. First, we have the temperature scanner and also the card reader, and then the data will be collected by the remote terminal unit here, and will send the data will transport to the online cloud database where it will store the data inside the internet, and then our application will pull the data from the storage to be displayed. So we use REST API, HTTP GET method to transfer the data. So these are basically the protocol that we use to send the data. Okay, so this is the web service framework. So the temperature with card scanner, the data we have sent to the database, it will store here. So this is our SALAM web service located inside the cloud or internet. It will gather the data from the database, and then it will display to our dashboard the distribution of patient, the distribution of attendees, the temperature, all of the data we can see here. Okay, so this is the external data analytic we can do. For example, we want to detect a faulty temperature sensor, or we want to predict the peak of high temperature attendee in at any moment. So we can alert the authority member. And then the last thing is we have the SALAM phone app. Okay, so the attendee tap his card, student card here, then she or he scan the temperature. Okay, so the student then will have to display this his or her app to the lecturer. Then lecturer will scan the QR code to match the data, and then this green will show the temperature is safe according to this temperature from the sensor temperature. If it's high, it will show red. So she or he have to get out from the class. Okay. So this is the hardware flow diagram. This is our application hardware. Okay, the K3 temperature scanner, which are very common in Malaysia, have seen throughout in Malaysia. Okay, I have explored that it contains body temperature and also the surrounding temperature. And the RFID, we capture the unique ID value. For example, you tap your IC number. We don't know what is your IC number. Instead, it will get the unique ID value, which we have to match in with the JPN. So the data is collected by the remote terminal unit. The remote terminal unit, we use Raspberry Pi computer. It act like your computer but in small form. Okay, so it will send the data to the database using Wi-Fi connection, where through Wi-Fi you use REST like previously I've shown you. HTTP GET is a method for transporting data. It will store inside the database, and our dashboard will pull the data from here to do the displaying, analytic, and so on. Okay, so this is our RTO diagram, the flow diagram. So this is our temperature scanner, our RFID card reader, and our contactless hand sanitizer. We also install the hand sanitizer, but it doesn't contribute any data to our system. It only gather the power from our Raspberry Pi computer. Okay. Okay. Before that, I want to show you our developed dashboard that we have already developed long time ago, that we used to observe the data inside the cloud. So this is Think Central. Okay. So I have did the hardware part, where we have to collect the sensor data, the temperature scanner, and also the RFID. So here is the body temperature that we gathered from our institution. But for the RFID reading, we haven't yet to to us because recently we have the COVID outbreak again. So yeah, we have no time to do that part. But after this, if the government allows the student to go back to the university and the staff to work, we have to use this system to make sure all the attendees is safe. And also we want to record the attendance too. We want to monitor how many people in a day, in a week, and also in a month that we will see in the dashboard in the next few slides. Okay, so we have come across this SALAM application. There is still being under development. This we have done, but we have to integrate the database to our system. This is all the work we have to do. So it's called e-kehadiran attendance system. Okay, so basically we have done for the masjid and also university. The hardware part I have already installed on Masjid UKM, Masjid Besi in Putrajaya, and also currently we are installing at our faculty, engineering faculty, for the attendance system. Yeah. But the COVID outbreak where we have to learn from home, so we have to adjourn our project. But we are developing the web part. Okay, so here is the example of our application in Masjid Tunku Mizan Zainal Abidin. This dummy data is not the real data. So we can see the daily data and also the distribution of the temperature. If we can monitor if this red region become larger, we have to be very cautious. We also have the weekly part here. We can see the distribution of in weekly term and also in monthly. Okay, so new user, of course, they have to register, especially for the lecturer. So we have the name of the student and the department and also the card ID, the student card ID, which they have to scan at the temperature scanner that we installed on the RTU. So here, the lecturer and student can see and monitor the distribution of the temperature, and also they can see the distribution of the attendance. Now we go to the next part, which is commercialization potential. If this we can market it to, if we can market or not. Okay, so this system, as we know, it automate most of the work, so it make the screening faster. And also we have put the price of 1,950. This include the RTU, which are ready to integrate to your existing data temperature scanner. That includes also with the web service and also phone application. Okay, so of course, this is to prevent the reoccurrence of the pandemic, and currently the case are very high. So we really need this project to make the disease management system more manageable by using IR4 or IoT. So now let's watch our project demonstration. This short video our team have did. So this is the student entering. You have to scan temperature and also the student card. And maintain sanitizer. And now you have to open the SALAM app. You will get the green because you scan. So this is the case for temperature higher than 7.5. So if we show red, that is during the lecture, so the student will show status. Green okay, red E or A, get out. So we can double confirm using the QR code. So that is basically is our concept. Okay, so we come to the result and discussion. So this the captured data that we have already do for some few months. This is the ambient temperature, and this one of the benefit that we have seen using IoT by integrating the online monitoring system, where we can detect faulty temperature scanner. Faulty temperature scanner will show 0. So if it happens frequently, we have to replace the unit. So from here, we can check whether the temperature sensor is okay or not. For the good temperature scanner, it will show some trend like this. It will have kind of jagged trend. Okay, so our project is very unique because of the dashboard we have developed. It's very high configurable, where if you don't like the QR code like you have watched inside the video, you can change it to RFID. And also it's very high configurable because you can just add the RQ as many as you want. For example, your institution have maybe 20 classes. You have to monitor. You have to put the RQ each of it. You can just add very easily, and very low cost for this system. If you add more hardware, of course, it will become cost efficient. That includes also the dashboard, the cloud dashboard, and it's very highly scalable to high level analytical process. Like I said, you want to do analytical purposes, you can use a lot of analytical tool from internet, or to predict something, or to predict event. For example, you want to predict from three days this place have to close, so you may have to use some algorithm AI. And also support Telegram, also SMS notification. If we have a high temperature individual, it will directly send the notification via Telegram and also SMS. And also we also send the malfunction detection unit. So this allows us to quickly react to the problem. And of course, this project operates on cloud architecture. So the society impact, it aims to reduce the COVID infection. Okay, and of course, it automates our work by the means of efficient COVID-19 spread management system, and it introduce digitalization in our COVID management system that will expose to the public. This is how we use digitalization. This is how it's work. So it will expose to the public, and also introduce the IR 4.0 element in our COVID-19 management system. So, of course, for the environmental impacts, by the means of digitalization, we avoid the use of paper, and all done via cloud. And also the process is very efficient and fast. Okay, so this is the long summary. You can pause to read, but I want to go to the points that I have created here. So this is the highly configurable web-based system. Of course, it will allow for the high scalability. You can add a lot of hardware, and also you can setting on your web dashboard how it will perform and do the data analytics and so on. Okay, so SALAM system ready to be integrated to widely used K3 temperature scanner, and it allows us to analyze the data collected to perform prediction, and also allow the user to detect faulty temperature from the analysis of the data collected, and allow the university instructor to double check the student temperature, such as the one I have shown you in, on the demonstration video. And currently, the RTU that we have developed already successful collect the data and transport it to the online cloud base. And now we are still under development for the smartphone application for the SALAM and also the dashboard, which most of it we have already finished. Just a few database connection we have to do, and also we have to prepare for the incoming new student. And currently we are working from home, so yes, we have ample time, a lot of time to do the development. I think that's all for our project. I believe this project is very beneficial to our society, to our country, to introduce the digitalization where the public can see it directly, and also they can appreciate the use of digitalization, and also educate in terms of IR 4.0. What is it? So they can see directly the direct application of it. And for that, I thank you for listening to my presentation. So I end this recording. Thank you.